We're going to solve the section 10.2 areas of trapezoids, rhombuses, and kites. Remember that the essential understanding, you're going to find the area of a trapezoid when you know its height, its length, and its bases. Also, today we're going to find the area of a trapezoid, rhombus, or a kite. So the first theorem that we have is the theorem 10.4, is the area of the trapezoid. But before we state the theorem, remember that the height of the trapezoid is the perpendicular distance between the bases. So in this case, we're going to call the bases these two segments. And I have base 1 and I have base 2. And the height is going to be this perpendicular line that is between the bases. So in this case, the area of a trapezoid is half the product, because we have a triangle there, of the height and the sum of the bases. So in this case, my formula is 1/2 the height, then times base 1 plus base 2. That's going to be my formula. We're going to use this formula. And example number 1 is, what is the approximate area of the state of Nevada? So we have this information, right? Nevada is a rhombus. And in this case, for the sake of this problem, we're going to assume this one is a right angle, okay? And the good thing about the paper is I can turn it around, and as you can see, I have a trapezoid. So this is going to be my bases, okay? This is base 1. I'm going to name this one base 1, and I'm going to make this one base 2. And my height is 309. This is going to be the height, 309. So if we apply the formula, we're going to have area equals to 1/2 height base 1 plus base 2 is the same as having 1/2 times the height is 309 times base 1, which is 205, plus 511. Remember the units, I'm going to leave them at the end, and I'm going to simplify. 1/2 309 times 205 plus 511 is 716. And then we can, if we want, multiply these two, and then we're going to divide by 2. And this one, if we plug it in the calculator, I have 1/2 times 309 times 716 is going to be equals to 110,622. And remember, the miles in this case is miles square, because it's an area. So in this case, it's an application problem. What is the approximate area of Nevada? The area of Nevada is about 110,600. It's an approximation, right? 600 miles square. If you write 622, is also fine. It's going to be correct. Okay, so we're going to have got it number 1. Okay, in this case, you are going to give it a try to got it number 1. So if you can just pause the video and try the problem, it's okay. But in this case, remember, what is the area of a trapezoid with the height of 7? I'm going to label height equals to 7 centimeters, and the bases 12 centimeters and 15 centimeters. So base 1 is equals to 12 centimeters, and base 2 is equals to 15 centimeters. Going to put the formula. So area is equals to 1/2 height base 1 plus base 2. So area is equals to 1/2 the height, which is 7, times 12 plus 15. And then we simplify. 12 plus 16 is 27. So this equals to 1/2 times 7 times 27. And if we multiply, we plug it in the calculator, 1/2 times 7 times 27 is equals to 94.5 centimeters square. What is the area? It's a question. The area of the trapezoid is 94.5 centimeters square. Okay, that's the solution. So example, got it, number 1. So let's move to example number 2, problem number 2. In this case, I have find the area using a right triangle. So what is the area of the trapezoid PQRS? So I have PQRS. Step number 1, I'm going to draw an imaginary line here. I have it here in the second triangle. And remember that this one, they are giving me that this angle here is 60. So what happened with that information? With this information, what's going to happen is that I'm going to create a triangle. And remember the previous chapter, this is 60. That means this is a 60, 30, 90 degree triangle. And according to the last chapter that we were doing, this base is 2. And in the formula we had, this one is x. This one here is 2x. And this height was x square root of 3. So if this one is 2, that means this one is 4. But we're not going to need that information in this problem. And this one is 2 square root of 3. So my height for this problem is equals to 2 square root of 3. And remember that the units are meters. And then we can say that base 1 is equals to 5 meters. And base 2, I need to be careful. This is 5, right? This is 7. 5 plus 2 is 7. So base 2 is equals to 7 meters. What is the area? Let's use the formula. Area is equals to 1/2 height base 1 plus base 2, which is equals to 1/2 times 2 square root of 3 times 5 plus 7. Let's simplify. 5 plus 7 is 12. And look at this one. 1/2 times 2 is 1. So these ones disappear. This 1/2 disappear with these 2. So I have square root of 3 times 12, or 12 square root of 3. And the units, remember, these are meters square. Therefore, these 3 dots means, therefore, the area of the trapezoid is, or the trapezoid PQRS is, this case, 12 square root of 3 meters squared. That's the solution. Got it? Number 2 is going to change slightly because it says in problem number 2, suppose that h decreases so that the measure of angle P, this one, is equals to 45 degrees, while angles R and Q and the bases stay the same. What is the area of trapezoid PQRS? So I'm changing my triangle. I'm changing my triangle to a 45. Okay, this one. So a 45, 90 degree triangle. And this is a special triangle again, like this example number 2. And remember that these ones were x, this one is x, and this one was x square root of 2. That's what we did in previous chapter. And remember that this segment is 2, so this one is 2, and my height is 2. So in this case, height is equals to 2, base 1 is equals to 5, and base 2 is equals to 7, and these ones are meters, okay? And the height is 2 meters. So my formula is equals to 1/2 height base 1 plus base 2 equals to 1/2 times 2, 5 plus 7 meters, and 1/2 times 2 is 1. I'm just going to cross them out. And what I have left is 12 meters square. Therefore, I'm going to answer the question, the area of the trapezoid PQRS is 12 meters square. Okay, so now you can find the area of rhombuses or a kite when you know the length of its diagonals. Now, this is a rhombus. We have diagonal 1, and every time we refer to diagonal 1, it's going to be from vertex to vertex, okay, not only half. And every time those diagonals crosses, they form a 90-degree angle. Okay, so we are going to end it with Pythagorean theorem if needed. So what is the formula? The area of a rhombus or a kite is half the product of the length of its diagonals. So in this case, the formula is area is equals to 1/2 diagonal 1 times diagonal 2. In this case, I'm going to say that the diagonals, the order of those diagonals is not important. You can have this diagonal 2 as diagonal 1 because the multiplication is commutative. So it's up to you what you want to do. If you want this D2 be your first diagonal, it's up to you. So example number 3, we're going to find the area of a kite. So I have a kite. Look at this diagonal LN, and I have KM. Now, in this case, I'm going to do KM. KM is equals to 2 plus 5, which is equals to 7 meters. And this is going to be my diagonal 1. Now, LN is equals to 3 plus 3, which is equals to 6 meters. And this is going to be my diagonal 2. And now what I'm going to do is just apply the formula. Area is equals to 1/2 diagonal 1 diagonal 2, which is equals to 1/2 diagonal 1 is 7 times diagonal 2 is 6. These are meters, and it's up to you which operation you want to do. I like to do 6 times 1/2 is 3. 3 times 7 is 21. 21 meters square is a question. I'm going to answer the question. Therefore, the area of kite, this case is KLMN, is 21 meters square. Got it? Number 3. What is the area of a kite with diagonals that are 12 inches and 9 inches? So they are giving me the diagonals in this case. So I'm not going to be looking at a figure. I'm going to say this one is diagonal 1 and this one is diagonal 2. And my formula in this case is area is equals to 1/2 diagonal 1 diagonal 2, which is equals to 1/2 12 times 9. If you want, you can do 12 divided by 2 is 6, and then 6 times 9 is 54, or you can just do 1/2. 12 times 9 is 108, and then you divide by 2. 108 divided times 1/2 is equals to 54, and the units are inches square. Answer the question. The area of the kite is 54 inches square. That's got it. Number 3. Now let's move to, for example number 4. I have an application problem. There is always an application problem at the end of the section. And what we have here is the problem says the high occupancy vehicle HOV lane is marked by a series of diamonds. So you're going to see these diamonds in some speedways or rhombuses painted on the pavement. what is the area of the HOV lane diamond shown at the right? So I have some figure. It's not very clear, this diamond. So this figure is a rhombus. Okay. Here. It's a rhombus, not a kite. That one looks like a kite. And they have that this diagonal here is 6.5. And this segment here is 2.5. This one is A, B, and C. Okay, so in this case, to solve this problem, what I'm going to do is find, because they are giving me the hypotenuse basically, this is a 90 degree, they are giving me the hypotenuse, and what I need is this height, because I need the value of the diagonal, and I don't have any value here. I do have this 2.5, and this one is 2.5, so it's 5. The diagonal, I'm going to say diagonal 2 is 5, but diagonal 1, I need to use the Pythagorean theorem. Remember, this is segment AB, so I'm going to have here AB squared plus 2.5 squared is equals to 6.5, the hypotenuse, 6.5 squared. Now, let's solve this theorem. So AB squared is equals to 6.5 squared minus 2.5 squared. You can right now apply the square root both sides. So I have that AB is equals to 42 square root, right? 42.25, that's 6.5 squared, minus 6.25, that's 2.5 to the second power, and this is the square root. If I simplify, 42.25 minus 6.25 is square root of 36. Square root of 36, 36 is a perfect square. So AB, segment AB is equals to 6, and in this case, remember the units are feet, 6 feet. This one is half of that diagonal. So that means, in this case, the diagonal 1, I'm going to put it here, diagonal 1 is 5, because 2.5 plus 2.5 here. 2.5 plus 2.5 is 5, and then diagonal 2 is equals to, in this case, we have 6 plus 6 is 12, and these are feet. Now I'm going to use the formula. Area is equals to 1/2 diagonal 1 diagonal 2, which is equals to 1/2 times 5 times 12, and it's up to you what you want to do. 12 divided by 2, or 12 times 1/2, is 6 times 5 equals to 30 feet square. Answer the question. The area, therefore, the area of the, in this case, is the high occupancy vehicle, HOV, lane, diamond, is 30 feet square. Okay, that's the solution for example number 4. Let's give it a try to get it. Number 4. So in this case, it says a rhombus has size 10 centimeters long. If the longer diagonal is 16, what is the area of the rhombus? So I'm going to draw a picture here. I'm going to draw a rhombus. Let's see how that turns out. So I have this one, and I'm going to the diagonal, I'm going to do another diagonal. And in this case, they are not giving me A, B, C, D. So this is 90 degrees. Has size of 10 centimeters. So this is 10, 10, 10, 10. And then if the longer diagonal is 16, if this is the longer diagonal, I'm going to say that's the longer diagonal. So that means this is 8 and this is 8. We're split it because they are congruent in a rhombus. So what is the area? So I do not have this diagonal. So I'm going to name this one X. X. And as you can see, I have a right triangle. So I'm going to use Pythagorean theorem. So I'm going to have X squared plus 8 squared equals to 10 squared. X squared is equals to, A squared goes to the right side. So 10 squared minus 8 squared let me simplify this time. X squared is equals to 100 minus 64. 100 minus 64 is 36, so x squared is equals to 36. Now I'm going to use the square root method, and because it's a triangle, we only use the positive, not the negative. This square goes away, so x is equals to the square root of 36 is 6. Remember that in this case the units are centimeters, and then I'm going to use the formula. Area is equals to 1/2 diagonal. This is diagonal, not base. Diagonal 1 times diagonal 2, which is equals to 1/2. Diagonal 1. What do you want diagonal 1? I'm going to make it 12. So 12, because 6 plus 6 is 12. So this one is 6, and 6 is going to be 12. Times diagonal 2, 16. It's up to you. You can multiply these two and then multiply by 1/2. So this is equals to 1/2. 12 times 16 is 192. And then 192 times 1/2, or 192 divided by 2, is equals to 96. The units, centimeters square. This is a question, so let's answer the question. Therefore, the area of the rhombus is 96 centimeters square, and that's the solution to the notes on section 10.2.